Hello, my name is Kevin Chen. I am a fourth year major in aerospace engineering. I am currently the structures sub-team lead at the UCI Rocket Project. The structures team basically deals with the design, manufacturing and implementation of the structures of the rocket. Those are such as the nose cone, the skin, the fins, the recovery system and the test stand. We implemented a plumbing system to our test stand to be able to test different engines, but we currently are testing our engine for the purpose of reaching 45,000 feet. The goal this quarter is to basically design the structures of our rocket capable of reaching 45,000 feet for our competition. And today I will be showing the design of our static test stand. We have been working in the design of this static test stand for the past 2 quarters with the idea of it being configurable and adaptable for different sizes of tanks and for different tests that we will be conducting in this stand. That's why we choose to have a unistrut as our main support, because we can adjust the sizes of it depending on the tanks that we'll be using for any specific test. At the bottom of the tanks, they're supported by a sheet metal that has also 3 holes with the same idea of it being configurable for different tests, and in case that we need to run different propellants for the test, we'll have the possibility to do so. At the bottom of the shelf, we have decided to use static hose or static tubes to minimize the error of using flexible tubing. These allow us to have better pressure readings and static sizing for the hoses. From the bottom, the hoses, the lugs will be split into 2 hoses that radially connects into the injector, and 1 hose for the fuel into the middle of the injector. We have also selected switch lock port adapters because they give us another degree of freedom when we are installing the pieces onto the test stand, and that allows us to be able to put everything in the same plane of symmetry. From the back of the static test stand, we have implemented pegboards, also with the idea of configuring different manifolds, solenoids, pressure transducers in the case that we need different readings or different data collection. The fuel for the pressurants that are going to be used to pressurize the entire system are coming from the bottom and allow the flow of it through a solenoid and a check valve that basically allows the flow to go only one way and not returning the flow into the tanks. And that's it. That's our UCI Rocket Project static fire test stand.